Hello students. In this lecture, we'll be talking about another question of linear spline interpolation. In this question, we have to check whether a function is linear spline or not. So in this question, we'll be checking the definition of the linear spline function, whether this function satisfies all the three conditions. So let us see. The three conditions that we have to check are, first of all, the function should pass through all the points. So here we are having uh, 4 points, minus 1, 0, 1 and 2. Minus 1 and 2 are the external nodes, 0 and 1 are the internal nodes. So second point is, on each subinterval the function is a linear polynomial. So as we can see, it is a linear polynomial. Third is that it is continuous in the open interval minus 1 comma 2. That means we have to check that the function is continuous at the internal nodes only, that is x is equal to 0 and x is equal to 1. So as the function is passing through all the points and on each subinterval it is a linear polynomial, so we are left with the last point only to check that the continuity at the internal nodes. So to check the continuity at x is equal to 0, I have to check that the limit at x tending to 0 negative of the function is equal to the limit at x tending to 0 positive of the spline function. Now, what is the left hand and the right hand limits? On the left hand limit, when we see limit x tending to 0 negative, 0 negative means that when the x is less than 0. So here you would see when x is less than 0, I am getting the function as s1, that is x. So in this first function, s1 will give me the x tending to 0 negative. So here I have written limit x tending to 0 s1, which is equal to limit x tending to 0 x. You just have to put the value of x here as 0 and the left hand limit will come out to be 0. Similarly, we'll find out the right hand limit, that is limit x tending to 0 positive s of x, that is at the function when x is greater than 0. So greater than 0 कब हो रहा है? जब आपका s2 के बारे में हम बात कर रहे हैं, and s2 here is 1 minus x. तो आपको उसको सब्सटीट्यूट करना है और जब आप लिमिट लगाएंगे इट वुड बी फ्रॉम x टेंडिंग टू 0. So x को 0 पुट करेंगे तो 1 minus 0 is coming out to be 1. So easily we can see that left hand limit is not equal to the right hand limit. So therefore the function is not continuous at x is equal to 0. Now, if we check the continuity at x is equal to 1 on the similar basis, my left hand limit is limit x tending to 1 negative of the function. 1 negative means when x is less than 1. So I am talking about s2. So जब आपने limit apply करी, so I'll get 1 minus 1, that is 0. Right hand limit will give me the 1 positive. तो x greater than 1 कब हो रहा है? जब हम s3 के बारे में बात कर रहे हैं. s3 is 2x minus 2. So वहाँ पे जब हम 1 को put करेंगे, I am getting 2 minus 2, again 0. So here my left hand and the right hand limit are equal. Now as the spline function is continuous at only one internal node and not the other one, therefore this function is not a linear spline function. So to check whether a function is linear spline or not, all the three conditions must be satisfied. Even one of the conditions is not satisfied, it means that it is not a linear spline function. So this is the end of the linear spline function, and in the next lecture we'll be talking about the quadratic spline function. Thank you.